Hello, in this video we would like to go through, or we will look into how can we apply the equation that we have, which G equals to sorry, it is not G. How can we calculate the mass, mass of any object that being orbited by another smaller object by using this formula where m equals to, what is the formula, 4 pi square r cube, divide by uh, g t square. Is it correct? 4 pi square r cube g t square, 4 pi square r cube g t square. Yes. So that is our formula. So how can we apply this formula? So before we go into our example, so again, this formula can be used to find the mass of any object. The mass of object which is at the center, that being resolved by the smaller object, orbiting this object, such as the moon orbiting the earth. So we can find the mass of earth, or earth orbiting the sun. We can find the mass of the sun. So we can find the mass of the object at the center by using the period, the period and the together with the distance from these two objects. So let's begin for our example. So in this question, this is the question which taken from your textbook. Figure 3.23 shows Mercury orbiting the Sun with a radius of 5.79 times 10 to the power of 10 meter and a period of revolution of 7.57 times 10 to the power of 6 seconds. Calculate the mass of the Sun. So in this question, they want us to find the mass of the object at the center, and we know that there is another object orbiting this object, which is the Sun, given the radius together with the period of together with the period of revolution, which means the time taken to completely move around this or on this orbit, on this orbit, and reach the same point again. So the time taken is 7.57 times 10 to the power of 6. So you may taken the information first. So what we have there, we have radius, r is equals to 5.79 times 10 to the power of 10. So in this kind of question, you don't need to sketch because the diagram is already given. So you can just try to understand the story behind this question. And a period, so it is given period, so the symbol for period is equals to 7.57 times 10 to power of 6 second. This one is meter. So those are base unit. Base unit in physics. Calculate the mass of the Sun. So they want us to find the mass of the Sun. You can write it as capital M or just ms. I would like to write as ms, mass of the Sun. What else? Of course we know the value of G, which is equals to 6.67 times 10 to power of negative 11. The unit is Newton meter square kilogram minus 2. So these are the information given. And then let's start with formula. So what the formula that we can use for this case? We want to find the mass and we have period. We want to relate between mass and period, or with the radius. We can use this equation that I just read before. So the equation is equals to m equals to 4 pi r square, 4 pi square r cube divided by gt square. Okay. And then what we're going to do, okay, we just need to substitute the value. So we shouldn't have quite space here. So let's write it here. So m equals to 4 pi. Okay, pi, you have pi in your calculator. Pi square r cube. Okay, let's open the bracket and then put your r there. 5.79 times 10 to power of 10 meter cube. Okay, meter cube divide by g. So g, your g 67 times 10 to power of minus 11 Newton meter square kilogram minus 2. Okay, together times with gt square. So the t, let's open bracket since we have square, 7.57 times 10 to power of 6 second square. So let's take out your calculator. Okay, so this is, where is our calculator? Okay, this is your calculator, and then let's insert the value. So 4 pi square, 4 pi square, where is pi? Okay, here, shift pi square, okay, times, okay, cube, we have cube, so we open bracket, 5.79, sorry, 79 times 10 to power of 10 times 10 to power of 10, close bracket, and cube. So do we have cube? Yes, here we have cube. So shift cube. So we'll get the upper part and then divide by the denominator, which is 6.67. Okay, 6.67. Of course, you can store this value in your calculator, in memory, or in any variables that we have here, a, b, c, d, e, f. It should be easier. 6.67 times 10 to power of negative 11. Okay, so we should guess this one, get this one, and then divide by square of 7.57 times 10 to power of 6. Let's square it, then we should get this number. Okay, so the mass of the sun here is equals to, the mass of the sun here is equals to, what's the value? Okay, what is the value? 2.00 times 10 to power of 30. Okay, 30. What is the unit? So mass should be kilogram, because we already use base unit in all of the variables. Of course, you can check the unit, okay, by do the same operation with the unit. So 4 and pi, we don't have unit. Here we have m and then cube power of 3 divide by, so we at the denominator we have Newton meter square kilogram minus 2, and here we have s square. Okay, s square. Okay, so let's change Newton to m cube. We can cancel out m first. Okay, m, here we have m square, so the upper part we have only m divided by Newton is kilogram meter per second square. Okay, divide by, okay, we have another m outside, m, and then we have kilogram minus 2, and here we have second square. Okay, So second square and second minus 2, we can cancel out. Minus 2 plus 2 equals to 0. Kilogram, okay, here we have kilogram, and this one is kilogram minus 2. So how can we cancel out? We cannot cancel out. So kilogram minus 2 plus 1, okay, kilogram power 1 times kilogram power minus 2. So it should be kilogram 1 minus 2. So kilogram minus 1. So we have m. Here we can cancel out, okay, 1 of m. Oh, sorry. Okay, this m. Okay, this m. There is no m at denominator. We just only this kind of m. Okay, so m and this m we can cancel out. Okay, cancel out. So the only unit that we have here is, okay, at the numerator we just only, okay, we have nothing. That means we have 1. Denominator we have kilogram minus 1. Okay, kilogram minus 1, which is equals to, okay, power of negative, you bring upward, it will become kilogram. So the unit is correct. Okay, the unit is correct. So that is the mass of the sun, which calculated by using uh, this equation. Okay, the equation which relates which relate the mass of object at the center together with the radius and period of another object which orbiting the center. Okay, so I think that's all for this example. If you have any question, you may ask through comment or through our Telegram group. Okay, that's all, and thank you.